What is a data? Data is a raw fact without any information or context, right? These are the data, right? Okay. Information is data, right? That has been processed, organized, or given meaning, right? If we add these numbers together, we can get the total, right? Let's see what is the total. Total is 253, right? This is the total, right? We can call this as an information, right? What is the data processing? Data processing is any operations that transforms raw data into meaningful information, right? Data processing is usually classified based on how the system handles and responds to data rather than just the storage method. There are three main types, right? First one is batch processing. In batch processing, data is collected over a period and then processed all at once, right? You can see the picture. Collect data over a period, process all data once, right? You can add this example. Bank process all days transactions at night, right? Second one is real-time processing. Data is processed immediately as it arrives. So, results are instantly available, right? Examples: ATM withdrawals and deposits, online ticket booking, and etc., right? If it happens instantly, it's real time, right? If it is waits, it's batch, right? Third one is interactive processing. Data processing directly involves user interactions, where the user requests something and gets an immediate response. Example, typing a query in Google search, right? We have more processing types than these three types, right? First one is manual data processing, right? That's the oldest method, right? In this type, data is processed by humans without use of machines or electronic devices, right? It involves tasks such as manual calculations, sorting, and recording, making it a time-consuming process, right? Another one is file-based processing. One of the earliest methods of handling data, right? Data is stored in separate files, often in flat files. Programs are written to read, write, and process these files, right? We have many problems in this type, right? Data redundancy, inconsistency, difficulty in accessing or updating data, right? Third one is database processing, right? These are the extra processing times, right? Developed after file-based systems to overcome the limitations of files, right? Data is centralized, structured, and can be queried efficiently, right? Supports multiple uses, ensures data integrity and reduce redundancy, right? What is the database? The database is organized collection of related data, right? It can be easily accessed, managed and updated, right? The database is stored in a structured form, right? Example, a university database stores students, courses, enrollments, right? Next, what is the database management system? It is a software that helps us work with a database, right? You can remember like this. Database is data storage. DBMS means the tool or software that manages that data, right? A DBMS allows us to insert it, update, delete, search, secure, protect data, right? Examples, MySQL, Oracle, SQL Server, right? Let's move on to the DBMS functionality, right? First one is data storage management, right? It stores data efficiently on disk, right? Think DBMS decides data is saved, right? Simply we can say it saves data efficiently, right? Sorry for the mistake. Think DBMS decides how data is saved, right? The second one is data retrieval, right? Which helps users quickly search for and retrieve data using SQL, right? Example is like this. Select all data from student. Using this, we can see all information about students, right? The third one is data manipulation that allows us to insert, delete and update data, right? Examples, adding a new student record, right? Simply remember that data manipulation is insertion and deletion, etc., right? The fourth one is data integrity management, which ensures data is correct, valid and consistent, right? Example, preventing two students with the same ID, right? Simply remember that data integrity keeps data correct and consistent. The fifth one is data security, which controls who can access which data, right? Example, admins can see salaries but students cannot, right? Simply remember that data security controls who can access data, right? The sixth one is concurrency control, which allows many users to access the database at the same time without conflicts, right? Example, two users editing different student records safely, right? Simply remember that concurrency control manages many users at once, right? The seventh one is a backup and recovery, which protects data from failures and restores it if corrupted, right? Example, power failure. DBMS restores last saved state, right? Simply remember that backup and recovery protect data from failures, right? The eighth one is data dictionary management, which stores metadata. Metadata means data about data, right? Example, you can see table name, right? And column types and constraints, right? Simply remember that the data dictionary stores metadata, right? The last one is transaction management, which ensures that multiple operations behave like a single unit, right? Example, money transfer must either fully happen or not happen, right? Simply remember that transaction management ensures ACID compliance, right? Let's move on to the database system environment, right? A database environment isn't just the database itself. It's everything around it, right? We can simply say the database environment system is the full ecosystem, right? Think of it like a whole ecosystem where the database is the heart, but everything else keeps it alive and running smoothly, right? A database environment has four main components, right? First one is hardware. It includes physical devices where the database lives, right? What are the examples? Servers, storage drivers, and network devices, right? The second one is software, which is the DBMS itself and any supporting tools. What are the examples? Oracle, MySQL, SQL Server. The third one is data, that the actual information you store and manage. It could be customer info, transaction records, and etc. Last one is users and procedures, right? Who are the users? Database administrators, developers, and end users, right? What are the procedures? Rules for security, access control, backups, and data integrity, right? What are the key jobs of DBMS? Manage data, control access, protect the data, ensure integrity, right? Why do we even need a DBMS instead of just using normal file-based storage? In file-based systems, data is stored in many separate files, right? Because of that, the same data might appear in multiple places and become inconsistent, right? Example, if our name is stored in 3 different files and only one file gets updated, right? Now the system has 3 different versions of our data, right? So why need a DBMS instead of file-based storage? No concurrency control, weak security, data redundancy, hard to share data, no data recovery, and data inconsistent, right? Those are the issues in file-based system. That's why we need a DBMS, right? Who are the main users in a database environment? There are 3 main types, right? Let's take one at a time, right? First one is database administrator, right? A DBA is like the main controller of the whole database, right? They handle security, backups, performance, accounts, and everything important, right? What are the main tasks a DBA handles, right? First one, security management. Who can access, what can they do, password and permissions, right? Second one is backup and recovery. Taking backups, restoring data or something goes wrong, right? Restoring data if something goes wrong, right? Third one is performance tuning. Making sure the database runs fast, fixing slow queries, right? Fourth one is data integrity, that ensures data is correct and consistent, right? Fifth one is creating and managing user accounts, right? Sixth one is database maintenance, right? Update, patches, monitoring, right? Please this question do yourself, right? Try it. The second user is application programmers or developers, right? They write programs that interact with the database, right? Example tasks: writing SQL queries inside applications, creating forms, reports, or APIs to use the database, ensuring applications store and retrieve data correctly. They don't usually manage the database, but they use its functionality through programs, right? Third one is end users. People who directly use the database applications to perform tasks. They don't need to know SQL or database internals, right? Example, bank tellers using a banking system, students checking their results online, customers using an e-commerce website, right? Think of a restaurant analogy, right? DBA like the chef, application programmer like the waiter, and end user like the customer, right? Advantages of using database. First one, data sharing. Multiple users and applications can access the same data easily, right? Second one, data integrity. Ensures accuracy and consistency of data through rules and constraints, right? Data security. Access can be controlled. Only authorized users can view or modify data, right? Third one is data security. No, we discussed it, right? Reduce data and redundancy. It is fourth one, right? Avoids duplicate data by centralizing storage, right? 1, 2, 3, 4, right? Fifth one, data independence. Changes in data structure don't require changes in programs using the data, right? Sixth one, efficient data access. Database use queries to retrieve data quickly, right? Seventh, backup and recovery. Easy to create backups and restore data in case of failure, right? And last one, enforced standards, right? Provides uniform data formats and naming conventions across applications, right? First one is complexity. Using a DBMS adds extra layers. You need skilled people to manage it, right? Cost. Setting up and maintaining a database system can be expensive. Training required. Users and developers need to learn how to use the DBMS properly, right? Next one, performance overhead. Sometimes queries and transactions can be slower due to extra processing, right? Next one, centralized control. While this is good for consistency, it can also create bottlenecks if the DBA is overloaded, right? If you get something from this video, don't forget to subscribe us, like, comment and share. Bye.